When you look up into the vast darkness of the night sky, you are not seeing the universe as it is right now. You are seeing a ghost, a fossil of light, that has traveled for billions of years just to reach your retina. We exist inside a sphere of visibility, a cosmic bubble defined strictly by the speed of light and the age of the universe itself. Beyond this fragile bubble lies a territory that humanity can never touch, never see, and never understand. Astronomers call this boundary the cosmic horizon, a hard limit on reality that imprisons us within a tiny fraction of the total cosmos. It is the wall of our celestial prison cell, and we have absolutely no idea who or what is walking on the other side. For centuries, we arrogantly assumed that the stars we see are all that exist, but mathematics suggests a terrifying alternative. The observable universe might be nothing more than a single grain of sand on an endless, dark beach that stretches into infinity. This is not science fiction. This is the direct implication of the theory of cosmic inflation, which dictates that space expanded faster than light. This means the vast majority of existence raced away from us before its light could ever hope to reach Earth. Imagine a ship lost in the middle of a boundless, dark ocean, where the crew can only see as far as their lanterns shine. We are that ship, drifting in the void, and the darkness beyond our light is not empty. It is hiding something massive. In 2008, researchers discovered something that defied the laws of standard cosmology and sent a chill through the scientific community. Clusters of galaxies were moving in a unified direction at tremendous speeds, drawn by an invisible force located beyond the edge of our map. They called this phenomenon the dark flow, a gravitational river sweeping millions of galaxies toward a specific point in the southern sky. Whatever is generating this gravity is massive enough to pull the universe apart, yet it sits silently beyond the observable horizon. If the laws of physics are consistent, gravity cannot exist without mass, which implies that a structure of unimaginable size lies hidden in the dark. We are being dragged toward a monster we cannot see, a cosmic leviathan waiting in the unobservable void. The terrifying reality is that light speed is not just a speed limit for travel, it is a speed limit for causality itself. Events happening right now, just past the horizon, are completely severed from our timeline, yet they might determine our ultimate fate. Consider the absolute isolation of our position. Entire civilizations could be rising and falling in the unobservable universe this very second. They could be screaming into the void or detonating stars, and their signals will simply never reach us because space is expanding too fast. We often look at the night sky and feel small, but the truth is far worse. We are becoming increasingly alone. As dark energy accelerates the expansion of the universe, more and more galaxies are being pushed across the horizon, vanishing from our sight forever. Every single second, a star somewhere in the cosmos crosses that point of no return, its light severed from Earth for all eternity. The universe is not just hiding its secrets, it is actively erasing the evidence, turning the lights out room by room. Future civilizations on Earth will look up and see nothing but endless black static, with no evidence that other galaxies ever existed. We are living in a privileged sliver of time, where we can still see the bars of our cage before the darkness becomes absolute. But the darkness is not the only thing we should fear. It is the possibility that the laws of physics change beyond the edge. Our observable universe might be a bubble of stability in a chaotic, boiling multiverse where atoms cannot hold themselves together. String theory proposes that our region of space settled into a specific energy state, allowing life to exist. Beyond the horizon, different vacuum states could exist, effectively creating a wall of death where matter instantly disintegrates upon contact. If a bubble of true vacuum nucleated in the unobservable universe, it would expand at the speed of light, destroying everything in its path. We would never see it coming. We would simply cease to exist the moment the wall of energy hit our planet. This concept, known as vacuum decay, is mathematically possible and statistically inevitable given enough time and space. The trigger for our destruction could have already been pulled a billion years ago, and the bullet is currently racing through the silence toward us. We cling to the comfort of the standard model, believing that the universe is uniform and predictable in all directions. But the cold spot in the cosmic microwave background suggests that our universe might have bruised against another universe entirely, leaving a scar on the sky. This anomaly is a region of space that is impossibly cold and vast, defying all current cosmological predictions. Some physicists argue it is the imprint of a parallel universe pressing against ours, a silent neighbor lurking just millimeters away in a higher dimension. If there are other universes or other patches of this universe with different laws, then we are merely a localized accident. The fine-tuning of gravity, electromagnetism, and the nuclear forces might just be a temporary roll of the dice in a chaotic, infinite casino. The observable universe is approximately 93 billion light-years in diameter, a number that sounds massive until you realize it is finite. If space is infinite, then every possible arrangement of particles must happen, meaning there are infinite versions of you doing this right now. This is the consequence of infinity. If you travel far enough, you will eventually find a copy of Earth that is identical down to the last atom. The horror lies in the fact that you will never reach it, separated by an ocean of expanding nothingness. But let us return to the physical threats, specifically the Great Attractor, a gravitational anomaly pulling our Milky Way at 600 kilometers per second. It lies in the zone of avoidance, hidden behind the dust of our own galaxy, obscured from our view like a predator in the bushes. We are hurtling toward this point with absolutely no way to stop, and we cannot even see what is reeling us in. It is a gravitational drain in the floor of the universe, swallowing galaxies whole, and we are circling the rim, waiting to fall. Even more disturbing is the Shapley supercluster, an even larger concentration of mass sitting behind the Great Attractor. It seems the further we look, the larger the monsters get, forming a chain of gravitational titans that dominate the structure of the cosmos. What happens when matter falls into these megastructures? Does it crunch into a singularity, or does it fuel something else? The sheer scale of energy involved makes our sun look like a dying ember, a flickering candle against a raging forest fire. The information paradox of black holes is troubling enough, but the horizon paradox of the universe is an existential nightmare. We are permanently cut off from the majority of reality, forced to construct theories based on a tiny, biased sample of data. Imagine trying to understand the entire history of human civilization by looking at a single photograph of a foot. That is exactly what we are doing when we look at the observable universe and claim to understand the nature of the whole. There is a distinct possibility that the universe is not expanding everywhere, but only in our local patch. Beyond the horizon, space could be collapsing, or static, or tearing itself apart in ways that our mathematics cannot even begin to describe. The darkness is not empty, it is heavy with the weight of the unknown, pressing against the edge of our vision. We send out radio signals, hoping for a reply, but perhaps the silence is the only thing keeping us safe from what lies beyond. The Fermi paradox asks where the aliens are, but the answer might be hidden by the expansion of space itself. An advanced civilization could have conquered 1 billion galaxies just past our horizon, and their light will simply never reach us to warn us. We are like an uncontacted tribe on an island, unaware that a global war is raging across the ocean. The isolation protects us, but it also leaves us vulnerable to forces we cannot anticipate until they arrive on our shores. Our telescopes act as time machines, but they are flawed time machines that can only see the past, never the present. We have no live feed of the universe. We are watching a delayed broadcast of a show that might have been canceled billions of years ago. The cosmic microwave background radiation is the oldest light we can see, the afterglow of the Big Bang itself. But even this baby picture of the universe contains anomalies, hot spots and cold spots, that hint at structures existing before the universe began. Sir Roger Penrose proposed conformal cyclic cosmology, suggesting our Big Bang was merely the death of a previous universe. If true, the ghosts of dead eons are imprinted on our sky, and we are living in the wreckage of a forgotten cosmos. This implies that time is not a straight line, but a terrifying loop of endless creation and destruction. We are trapped in a cycle of eternal recurrence, destined to repeat the same mistakes, the same wars, and the same extinctions forever. The concept of the edge of the universe is a misnomer. There is no physical wall, only a limit to information. But information is reality, and when information is lost, reality itself becomes fragmented, incomplete, and fundamentally terrifying. Quantum entanglement suggests particles can communicate instantly over any distance, seemingly defying the speed of light. Could this be the key to unlocking the unobservable? Or is it a trap, a way for something outside to reach in and manipulate us? We are built of atoms that were forged in stars that are now dead, scattered across a galaxy that is rushing away from its neighbors. We are debris in an explosion that hasn't finished happening, trying to find meaning in the smoke. The Hubble Space Telescope showed us the deep field, thousands of galaxies in a patch of sky the size of a grain of sand. Now imagine that every grain of sand on Earth holds that many galaxies, and realize that is still only the beginning. The numbers are so large they become meaningless to the human brain, triggering a defense mechanism known as cosmic vertigo. We shut down because the scale of our insignificance is too traumatic to process without descending into madness. But we must look. We must stare into the abyss until our eyes bleed, because ignorance is not safety. If something is coming from beyond the horizon, be it a vacuum decay bubble or a gravitational collapse, we owe it to ourselves to see it coming. The James Webb Space Telescope is now peering closer to the beginning of time than ever before, hunting for the first stars. But what if it finds something that shouldn't be there? A structure older than the Big Bang? A shadow cast by the unobservable? We have already found galaxies that are too big, too early, challenging our standard model of cosmic evolution. These universe breakers suggest that the timeline we have constructed is a lie, or at least a gross oversimplification of a violent truth. Every discovery we make pushes the darkness back by an inch, but reveals a mile of new questions. We are digging a hole in the sand while the tide is coming in, desperate to find bedrock before the ocean swallows us whole. The ultimate question remains, is the universe infinite? If it is, then everything that can happen is happening. If it is finite, then what lies outside the boundary? Is it nothing? Or is it a realm where physics dissolves into nightmare? We might be living in a simulation, a computer struggling to render the distant universe, explaining why we have a horizon. The fog of war in our cosmic video game keeps us from seeing the processors that run our reality. This theory would explain the limits of light speed. It is the clock speed of the universal processor. We are trapped in code, and the unobservable universe is simply the data that hasn't been loaded into memory yet. Whether we are in a simulation, a multiverse, or a dying bubble, one fact remains undeniably true. We are fragile, we are isolated, and the things we cannot see are far more powerful than the things we can. To truly understand the horror of our situation, we must first dissect the very concept of the observable universe. It is not a physical barrier, like a wall or a cliff edge, but rather a temporal prison constructed by the finite speed of light. When we look at the farthest galaxies captured by the James Webb Space Telescope, we are not seeing them as they are today. We are seeing them as they were billions of years ago, in their infancy. The light from their current state, their middle age, their death, their potential technological civilizations, is still traversing the void, racing toward us but doomed to never arrive. We are trapped in a bubble of past, surrounded by a present that is physically disconnected from our reality. The distance to this horizon is approximately 46 billion light-years, a number that seems astronomical but is actually a suffocatingly small cage when compared to the theoretical size of the entire cosmos. We are studying ancient history while the universe evolves in the dark, and the realization that we are cut off from the now of the universe is the first step in understanding our profound isolation. The speed of light, 299, 792, 458 meters per second, is often described as incredibly fast, but on the scale of the cosmos, it is agonizingly slow. It is a snail crawling across a continent. This speed limit is the fundamental reason for our ignorance. It creates a lag in the causal structure of the universe that cannot be overcome. Imagine a thunderclap happening on the other side of the planet, but the sound takes 10 billion years to reach you. By the time you hear it, the storm has passed, the landscape has eroded, and the civilization that witnessed the lightning has turned to dust. This is our relationship with the cosmos. We're watching a silent movie that ended eons ago, trying to reconstruct the plot of a story that has already moved on to its sequel. The terrifying implication is that if a catastrophic event, a tear in the fabric of space or a wave of destruction, were triggered just outside our horizon, we would have absolutely no warning until it was already upon us. The speed of light is not just a carrier of information, it is the blindfold that keeps us calm before the execution. We must also grapple with the counterintuitive nature of co-moving distance. The universe is expanding, stretching the fabric of space-time between us and distant objects. This means that a galaxy whose light took 13 billion years to reach us is not 13 billion light-years away. It is now over 46 billion light-years away. It has been carried away by the tide of expansion, while its light was swimming upstream toward Earth. Many of these objects are now moving away from us faster than the speed of light. This does not violate Einstein's theory of relativity, as it is space itself that is expanding, not the objects moving through it. However, the consequence is chilling. These galaxies have passed beyond our future visibility limit. Even if we sent a signal today, traveling at the speed of light, it would never, ever reach them. They have permanently disconnected from our causal timeline. They are lost to us, effectively deleted from our version of reality, existing only as ghosts in our telescopes. This expansion leads us to the horizon problem, a paradox that haunted cosmologists for decades and eventually led to the theory of inflation. When we look at the cosmic microwave background, the afterglow of the Big Bang, we see a uniform temperature across the entire sky. It is smooth, consistent, and isotropic. But this shouldn't be possible. In the standard Big Bang model, the opposite sides of the observable universe are too far apart to have ever been in contact with each other. There hasn't been enough time since the beginning of the universe for heat to travel from one side to the other to equalize the temperature. It is as if you handed a cup of coffee to two people on opposite sides of the Earth, and they both cooled down to the exact same micro-degree at the exact same moment without ever communicating. This coincidence is statistically impossible, implying that our model of the universe was missing a massive, violent piece of the puzzle that occurred in the first fraction of a second. The solution to the horizon problem is cosmic inflation, a theory proposed by Alan Guth in 1980, which suggests that in the first 10 to the power of minus 36 seconds of existence, the universe expanded exponentially. It grew from the size of a subatomic particle to the size of a grapefruit, and then continued outward in less time than it takes light to cross a nucleus. This violence explains the uniformity. Everything we see was once a tiny speck in thermal contact, before being ripped apart faster than the speed of light. But while inflation solves the temperature problem, it introduces a scale of horror that is difficult to comprehend. If inflation occurred, it means the observable universe is merely a microscopic patch on the skin of a much, much larger beast. The true universe could be 10 to the power of 23 times larger than what we can see. To put that in perspective, if the observable universe were the size of a light bulb, the entire universe would be larger than the planet Pluto. We are studying a single atom and claiming to understand the mountain. This leads us to the concept of eternal inflation. In many versions of this theory, the expansion of space doesn't stop everywhere at once. It stops in localized bubbles, like ours, allowing stars and galaxies to form. But the space between these bubbles continues to inflate eternally, pushing the universes apart at speeds that make light look stationary. This implies a multiverse scenario, not in the sense of parallel dimensions, but as different pockets of stable space-time, separated by an eternally expanding void. We are living in a quiet clearing in a forest that is growing infinitely fast in all directions. We can never leave our clearing, and we can never see the other clearings. We are completely, utterly isolated. The laws of physics in those other bubbles might be entirely different. Gravity might be repulsive. Light might not exist. Matter might be unstable. We are drifting in a rare, habitable life raft on an infinite ocean of chaotic, expanding deadliness. But we don't have to look to the theoretical multiverse to find existential threats. We have dark energy right here in our own bubble. Discovered in the late 1990s, dark energy is the mysterious force that is accelerating the expansion of the universe. It is not just stretching space, it is stretching it faster and faster every second. This discovery destroyed the comforting notion that the universe would eventually slow down and stabilize. Instead, it is tearing itself apart. Dark energy makes up roughly 68% of the total energy budget of the cosmos, yet we have absolutely no idea what it is. It is an invisible hand pushing the galaxies away from us, isolating the Milky Way. It is the ultimate anti-gravity, a repulsive force that dominates the large-scale structure of reality. If this acceleration continues, it leads to a scenario known as the Big Freeze or heat death, where the universe becomes cold, dark, and empty. But if the acceleration increases, it leads to something far more violent. This violent alternative is the Big Rip. If the density of dark energy increases over time, a scenario known as phantom energy, then the expansion will eventually overcome the gravitational forces holding galaxies together. Then, it will overcome the gravity holding solar systems together. Finally, it will overpower the electromagnetic and nuclear forces. In the final moments of the universe, stars will be stripped from their galaxies, planets will be ripped from their stars, and eventually, atoms themselves will be torn apart. Your body, the Earth, the Sun, everything will be shredded into subatomic particles by the expanding vacuum of space itself. This is not a sci-fi fantasy. It is a mathematically valid solution to the equations of general relativity if the parameter of dark energy behaves in a specific way. We are sitting on a bomb that is currently counting down, and we cannot see the timer because it is hidden in the properties of empty space. Even without the Big Rip, the future of our observable universe is bleak. As the expansion accelerates, the cosmic horizon effectively shrinks relative to the galaxies. We are losing contact with the cosmos. In roughly 2 trillion years, all galaxies outside our local group, the Milky Way, Andromeda, and a few dozen dwarfs, will have crossed the horizon and vanished from view. They will be moving away faster than light, and their light will never reach us again. A future astronomer born in that era will look up and see nothing, just a static dark void surrounding a merged Milky galaxy. They will have no evidence of the Big Bang, no evidence of expansion, no evidence of other galaxies. They will construct a model of the universe that is completely wrong, believing they are the only island of matter in an infinite void, and they will have no way of knowing the truth. We are the privileged few who live in the brief window of time where the universe is transparent enough to reveal its origin. But the standard model of cosmology, despite its successes, is starting to show cracks. It assumes that on large scales, the universe is homogeneous and isotropic, meaning it looks the same in every direction and matter is spread out evenly. This is the cosmological principle, the bedrock of modern astronomy. If this principle is wrong, then everything we think we know about the age, size, and fate of the universe is wrong. And recently, data has emerged that suggests the universe is not the same in all directions. We are seeing anisotropies, lopsidedness, that shouldn't exist. Large structures, vast flows of motion, and temperature fluctuations that hint at a monstrous influence lurking just beyond the edge of our vision. The universe is tilting, and we are sliding toward something. The investigation into these anomalies changes the genre of our reality, from a history documentary to a cosmic horror story. Enter the mystery of the dark flow. In 2008, a team of astronomers led by Alexander Kashlinsky at NASA's Goddard Space Flight Center found something impossible. They were studying the motion of galaxy clusters, massive groupings of hundreds of galaxies bound by gravity. According to the standard model, these clusters should be moving randomly, expanding outward with the general flow of the universe. But they weren't. Kashlinsky found that hundreds of galaxy clusters were moving in a unified stream, rushing at a staggering 800 kilometers per second, nearly 2 million miles per hour, toward a specific patch of sky between the constellations of Centaurus and Hydra. This wasn't a random drift. It was a coordinated migration. It was as if the entire universe was being tilted on a table, and all the matter was sliding down into a corner. This motion cannot be explained by the known distribution of matter in the observable universe. The implications of dark flow are terrifying because gravity requires mass. For these galaxy clusters to be moving at such speeds, something with immense gravitational pull must be attracting them. However, when we look in the direction of the flow, towards Centaurus and Hydra, we see nothing in our observable universe massive enough to account for it. There are galaxies there, sure, but not enough to drag a substantial portion of the cosmos across the sky. The logical conclusion, accepted by the researchers, is that the source of this gravity lies beyond the cosmic horizon. We are being tugged by a structure of matter that is technically outside our universe. Imagine standing in a dark room and feeling a hand grab your ankle and pull. You can't see the hand, you can't see the person, but you can feel the force. That is the dark flow. Critics argued that the dark flow data might be a mistake, a statistical fluke in the way we measure the cosmic microwave background, but subsequent studies have largely supported the existence of this dipole anisotropy. The universe really does seem to have a preferred direction. This challenges the cosmological principle at its core. If there is a massive structure just outside our horizon pulling us, it means the universe is not uniform. It means the bubble we live in is part of a much larger asymmetrical system. What could be big enough to pull galaxy clusters across billions of light years? A super cluster, a knot in the texture of space-time, or perhaps the hull of another bubble universe pressing against ours. The sheer scale of the requisite mass is mind-breaking. It suggests that what we call the universe is just a small, debris-filled suburb of a much larger, denser metropolis that we are forbidden from seeing. While the dark flow hints at monsters beyond the horizon, we have verified monsters lurking within our own backyard, obscured by dust. The most famous of these is the Great Attractor. For decades, astronomers noticed that the Milky Way and our neighboring galaxies, the Local Group, were moving through space toward a strange gravitational anomaly. We are hurtling at 600 kilometers per second toward a point in the sky that, for a long time, was completely invisible to us. This region lies in the zone of avoidance, the area of the sky obscured by the dense plane of our own Milky Way galaxy. It was the ultimate cosmic hiding spot. We were being reeled in by a fisherman we couldn't see because our own boat was blocking the view. When X-ray astronomy finally allowed us to peer through the dust, we found a gravitational titan, a supercluster of galaxies called the Laniakea supercluster. But even that wasn't enough to explain the speed. The Great Attractor turned out to be a red herring, or rather, just the tip of the iceberg. The mass of the Great Attractor was calculated, and it was massive, tens of thousands of Milky Ways, but it wasn't massive enough to generate the pull we were experiencing. There was a deficit in the gravitational budget. Astronomers looked deeper, behind the Great Attractor, and found something far more terrifying: the Shapley supercluster. This is the most massive concentration of galaxies in the nearby universe. A behemoth containing over 8,000 galaxies, located 650 million light-years away. It is a gravitational drain in the floor of the universe, and we are all sliding toward it. But here is the twist. Even the Shapley supercluster doesn't fully account for the motion. The dark flow data suggests there is something even bigger behind Shapley, further out, perhaps past the horizon. It's monsters all the way down. To make matters worse, we aren't just being pulled, we are being pushed. In 2017, astronomers mapping the flows of the local universe discovered the dipole repeller. While the Shapley supercluster is a region of intense density pulling us in, the dipole repeller is a vast, empty void sitting directly opposite it. It is a region of space with almost no galaxies, a cosmic vacuum. Because it is so empty, the gravitational pull from that direction is weaker than average, effectively acting as a repulsive force. We are caught in a cosmic riptide, sandwiched between a mountain of matter and a canyon of nothingness. The terrifying realization is that the structure of the universe is defined as much by what isn't there as what is. These voids, the Boots void, the dipole repeller, grow larger as the universe expands, isolating the clusters of matter into thin filaments. We are inhabitants of a dying web, being swept toward the drain. This large-scale movement of the universe brings us back to the cosmic microwave background, CMB, the ancient light that serves as the backdrop for all these mysteries. The CMB is supposed to be the perfect echo of the Big Bang, random and uniform. But it isn't. There is a region in the southern hemisphere known as the CMB cold spot. It is a massive patch of sky, roughly 1.8 billion light-years across, that is significantly colder, about 0.00015 degrees Kelvin, than the surroundings. In the world of precision cosmology, this is a gaping wound. Statistical models predict that a cold spot of this size and intensity should theoretically rarely occur. It is a 3 sigma anomaly. It shouldn't be there. It is a giant blue eye staring back at us from the edge of time, and standard physics has struggled to blink it away. The leading conventional explanation for the cold spot is the Eridanus supervoid. The theory suggests that there is a massive region of empty space between us and the CMB in that direction. As the ancient light travels through this void, it loses energy due to the expansion of space, the integrated Sachs-Wolf effect, appearing colder when it reaches us. But for this to work, The void would have to be impossibly huge, a cavern of nothingness spanning billions of light years, far larger than any void we have ever observed or modeled. It would be a structure that defies our understanding of how matter clumps together. If the supervoid exists, it is the largest structure in the observable universe, and it is made of absolutely nothing. It is an abyss so deep that it chills the light of creation itself. However, there is a darker, more exotic explanation for the cold spot, championed by theoretical physicists like Laura Mersini-Houghton. She proposes that the cold spot is not a void, but a bruise, a scar. In the chaotic moments of the early universe, or perhaps before our universe even fully formed, our bubble of space-time might have collided with another bubble universe. This multiverse collision would have released an incomprehensible amount of energy, leaving a permanent imprint on the thermal map of our cosmos. The cold spot is the impact crater. If this theory is true, it is the first physical evidence that the multiverse is real, and that other universes are crowding us. It implies that our reality is just one balloon in a bag full of balloons, rubbing against its neighbors, squeaking in the dark. The unobservable isn't just distance. It's a different dimension of existence pressing against our walls. The anomalies in the cosmic microwave background don't stop at the cold spot. There is also the axis of evil. This is not a political term, but a statistical one given by cosmologists. When analyzing the fluctuations in the CMB, scientists found a strange alignment. The hot and cold patches seem to be aligned with the plane of our own solar system and the motion of our galaxy. This is a catastrophic violation of the Copernican principle, which states that Earth is not in a special or central position in the universe. Why would the oldest light in the universe, emitted 13.8 billion years ago, care about the orientation of the Earth, which wouldn't exist for another 9 billion years? It suggests that either our measurements are critically flawed, or the universe has a weird intrinsic geometry that centers on us. Or perhaps what we see as the universe is an illusion or a simulation oriented for the observer's benefit. The axis of evil makes astronomers incredibly uncomfortable, because it hints that our entire cosmology might be built on a house of cards. If the universe is not isotropic, if it has a preferred direction or an alignment with us, then our calculations for the distance of stars, the age of the universe, and the amount of dark matter could all be biased. It's like realizing the map you've been using to navigate the ocean was drawn by someone who never left the harbor. Some attribute this to calibration errors or local dust, desperate to wash away the anomaly. But the signal persists in data from multiple satellites, COBE, WMAP, and Planck. It is a stubborn ghost that refuses to be exorcised, whispering that our fundamental assumption of mediocrity, that we are nothing special, might be wrong in the most terrifying way possible. We might be centrally significant to the structure of this reality. While we look outward, the very fabric of space is stretching at a rate that confuses us. This is the Hubble tension. We have two main ways to measure how fast the universe is expanding: the Hubble constant. One method involves looking at the early universe, the CMB, and projecting forward. The other involves looking at the late universe, supernovae and pulsating stars, and measuring directly. The problem is, the numbers don't match. The early universe predicts a slower expansion, 67 kilometers per second MPC, while the local universe shows a faster expansion, 73 kilometers per second MPC. This discrepancy has reached a level of statistical significance, 5 sigma, that means it is not a fluke. It means we are missing something fundamental about the physics of the universe. Is dark energy changing over time? Is there a new type of particle we haven't found? Or is the unobservable universe exerting an influence on our local measurements that we can't account for? The ruler we use to measure reality is broken. The James Webb Space Telescope, JWST, was launched to solve these mysteries, but it has arguably deepened the crisis. JWST has spotted galaxies that existed only 300 to 500 million years after the Big Bang. According to our standard models, these galaxies should be small, messy, infant blobs of gas. Instead, many of them are massive, bright, and well-structured, with fully formed disks. They are universe breakers. They are too big, too early. It's like walking into a nursery and finding a fully grown adult sitting in a crib. These discoveries suggest that the timeline of the universe is not what we thought. Did structure form faster than physics allows? Or is the universe actually older than 13.8 billion years? If the timeline is wrong, then the horizon is wrong, and the boundary of the unobservable shifts into the realm of the impossible. Let us descend into the quantum realm to find the scariest threat from the unobservable: vacuum decay. The universe is filled with fields, like the magnetic field or the gravitational field. One of these is the Higgs field, responsible for giving particles mass. The stability of our universe depends on the value of the Higgs field being at its lowest possible energy state, the bottom of the valley. But recent measurements of the mass of the Higgs boson and the top quark suggest that we are not at the bottom. We are in a false vacuum, a little ledge on the side of the valley. We are metastable. This means we are stable for now, but not forever. At any moment, a quantum tunneling event could occur where a tiny bubble of the Higgs field drops to the true lower energy state. If this tunneling happens, it creates a bubble of true vacuum. Inside this bubble, the laws of physics would be completely rewritten. The constants of nature would change. Chemistry would become impossible. Atoms would not hold together. And this bubble would expand at the speed of light. Because it expands at light speed, you would never see it coming. We wouldn't see a flash or hear a rumble. One moment you are reading this, and the next moment you and the entire Earth simply cease to exist as coherent matter. The terrifying part is that this event could have already started a billion years ago in a distant galaxy. The wall of death is racing toward us right now, devouring star systems in silence, and we will continue to live our lives in blissful ignorance until the very nanosecond it hits us. Vacuum decay is the ultimate cosmic horror because it renders all struggle, all history, and all future potential meaningless. It is the formatting of the hard drive. And the unobservable universe plays a key role here. Because the universe is so vast, possibly infinite, the probability of a vacuum decay event occurring somewhere approaches 100%. If space is infinite, then a bubble has certainly nucleated. The only question is, how far away is it? Is the expansion of space pushing it away faster than it can grow toward us? Or is it closing the distance? We are betting our existence on the race between the expansion of the void and the expansion of the death bubble. It is a race we have no way of watching and no way of winning. Then there is the question of primordial black holes. These are hypothetical black holes that formed not from dying stars, but from the direct collapse of dense matter in the first second after the Big Bang. Some theories suggest the universe is filled with them, acting as a component of dark matter. But what if there are monster primordial black holes lurking in the unobservable universe? Black holes with the mass of 1 billion suns wandering the dark, older than the stars themselves. The gravitational waves from such behemoths would ripple through space-time's subtle distortions that might be affecting our galaxy's motion. We are sailing through a minefield of invisible gravitational sinkholes, remnants of a violent birth we can barely comprehend. The concept of the Great Filter in the Fermi paradox suggests that there is a barrier to life that makes advanced civilizations incredibly rare. Usually we think of nuclear war or climate change. But what if the Great Filter is cosmic in nature? What if the universe is periodically sterilized by events from the unobservable sector? Gamma ray bursts, vacuum decay bubbles, or wandering rogue supermassive black holes. Perhaps we are alone not because life is rare, but because life is fragile, and the universe is a violent, hostile place that wipes the slate clean every few billion years. We might be the first to arise in this current cycle of calm, or simply the last ones left alive in a graveyard of galaxies. Consider the von Neumann probe scenario. An advanced civilization could build self-replicating spacecraft that spread from system to system. Even at sublight speeds, they could colonize a galaxy in a few million years. If the universe is infinite, or just vastly larger than the observable part, then such civilizations should exist. So why aren't they here? The Berserker hypothesis suggests that there are automated killer probes patrolling the cosmos, programmed to extinguish any civilization that gets too loud. By broadcasting our radio signals and hello messages into the void, we are effectively lighting a flare in a dark forest full of wolves. The silence of the unobservable universe isn't empty, it's tactical. Everyone else knows to stay quiet. We must also address the dark sector of particle physics. Dark matter makes up 27% of the universe, and dark energy 68%. Normal matter, us, stars, gas, is only 5%. This means 95% of the universe is made of stuff we cannot see, touch, or interact with, except through gravity. It is possible that there is a shadow biosphere or a dark universe coexisting with ours. There could be dark stars burning with dark fusion, dark planets orbiting them, and perhaps even dark life. These entities could be passing right through us, unaware of our existence, just as we are unaware of theirs. We are ghosts to each other, occupying the same space but separated by the fundamental forces of nature. The unobservable isn't just far away, it might be right here in this room. String theory creates a landscape of possibilities known as the string landscape, estimating 10 to the power of 500 different possible vacuum states. Each valley in this landscape represents a different set of physical laws. Our universe corresponds to just one of these valleys. The unobservable universe, under the chaotic conditions of eternal inflation, creates pocket universes that sample all these different valleys. This leads to the anthropic principle. We are here because we can be here. In most of those other pockets, electrons might be too heavy to form atoms, or gravity might be too strong, crushing everything instantly. We look out and see a universe perfectly tuned for life, not because of design, but because of survivorship bias. We are the lottery winners in a casino where every other player died at the table. But this multiverse idea introduces the horror of the Boltzmann brain. If the universe is eternal and infinite, then random thermal fluctuations will eventually, given enough time, assemble atoms into a conscious brain, complete with false memories of a life that never happened. It is statistically more likely for a single brain to spontaneously form in the void than for an entire orderly universe like ours to evolve from a Big Bang. This leads to the terrifying thought: are you a real human being with a past? Or did you just hallucinate into existence a microsecond ago, floating in deep space, and will dissolve back into chaos a microsecond from now? The logic of infinity makes reality unstable. Let's return to the physical mapping of our predicament. We have identified the Laniakea supercluster as our home, but even Laniakea is moving. It is flowing toward the Shapley supercluster, but recent studies suggest Laniakea itself is just an appendage of a much larger structure, possibly the Vela supercluster, which is hidden behind the galactic plane. We are finding that the universe is webbed with filaments of matter, vast bridges of gas and galaxies connecting superclusters. We are barely an insect crawling on one thread of a spiderweb that spans billions of light years. And we can't see the spider. The large-scale structure of the universe looks eerily like a neural network, a brain. Are we neurons in a cosmic mind? The concept of time past the observable horizon gets murky. In general relativity, time is relative to the observer. But if we can never communicate with the unobservable regions, do they even share a now with us? Some physicists argue that asking what is happening right now in a galaxy 100 billion light-years away is a meaningless question. Without causal connection, reality bifurcates. The unobservable universe exists in a state of quantum superposition relative to us. It is both dead and alive, safe and dangerous, there and not there. We are only real to the things we can touch. To the rest of the cosmos, we do not exist. There is a theory called brain cosmology, derived from M-theory. It suggests our 3D universe is a membrane, a brain, floating in a higher dimensional bulk, hyperspace. We are like 2D drawings stuck on a sheet of paper, unable to perceive the 3D room we are in. In this model, the Big Bang was caused by two brains colliding, an ekpyrotic universe. The terror here is that the brains could collide again. At any moment, another universe could slam into ours from the fourth dimension, resetting all matter and energy, initiating a new Big Bang and wiping us out instantly. We would never see it coming because light is trapped on our brain. We cannot look up into the bulk to see the approaching catastrophe. If the universe is cyclic, a series of big bangs and big crunches or big bounces, then the unobservable universe might contain fossils from the previous eon. Sir Roger Penrose calls these Hawking points regions where supermassive black holes from the last universe evaporated, leaving a mark on our sky. If this is true, the universe is a graveyard. We are walking on the bones of civilizations that existed trillions of years before our sun was born. They faced the same end we face, and they left nothing behind but cold spots in the microwave background. It renders our struggles for legacy utterly futile. The cycle will grind us down and restart, again and again, for eternity. The Boots Void, often called the Great Nothing, is a sphere of space 330 million light-years in diameter that contains very few galaxies. If the Milky Way were in the center of the Boots Void, we would not have known other galaxies existed until the 1960s. We would have thought we were truly alone in an infinite darkness. It serves as a reminder of how much our location dictates our philosophy. What if we are in a relatively empty patch of the greater universe? What if the true universe is dense with life and matter, and we are exiled in a barren wasteland, a cosmic desert where life is not supposed to survive? The silence we hear might just be the wind howling through the empty quarter. We rely on standard candles, stars with known brightness, Cepheid variables, and type Ia supernovae to measure distances. This is the ladder we use to map the dark. But what if the ladder is broken? If the fundamental constants of physics vary across the universe, as some theories of the unobservable suggest, then a supernova far away might be dimmer or brighter than one nearby for reasons we don't understand. This would mean our map of the cosmos is distorted. We might think the universe is expanding when it isn't, or that it's younger than it is. We are navigating a treacherous ocean with a compass that points to a shifting magnetic pull. The mystery of Tabby's star, KIC 8,462,852, brought the concept of alien megastructures into the mainstream. The star dimmed erratically, leading some to hypothesize a Dyson swarm was being built. While dust is the likely culprit, the idea persists. If a Type 3 civilization on the Kardashev scale existed, one that controls the energy of an entire galaxy, they would be visible to us by their waste heat, infrared radiation. We have scanned millions of galaxies and found nothing. No obvious galactic empires. This great silence reinforces the horror. Either we are the first, or something effectively kills civilizations before they can conquer the stars. The unobservable universe might be littered with the ruins of those who tried. Let's talk about strange matter. Inside the pressure cooker of neutron stars, protons and neutrons break down into quarks. It is hypothesized that strange quark matter is the true ground state of matter, more stable than the matter we are made of. If a microscopic piece of strange matter, a strangelet, were to drift into our solar system and touch Earth, it would trigger a reaction, converting all normal matter into strange matter. The Earth would be consumed and transformed into a hot, dense lump of quark soup. These strangelets could be ejected from neutron star collisions, drifting through the unobservable void like cosmic mines, waiting to drift across our path. We are biologically ill-equipped to understand these scales. Our brains evolved to find fruit and avoid tigers on the African savanna, not to comprehend 93 billion light-years of expanding space-time. The feeling of cosmic horror, or existential dread, is simply our cognitive hardware overheating. We are trying to run a simulation of the infinite on a processor designed for survival in a tribe of 150 people. It is no wonder that the unobservable universe feels like a threat. To a primitive brain, the unknown is always a predator. But in this case, the predator is real, and it is the universe itself. The concept of the end of greatness is a cosmological term. It refers to the scale at which the universe stops looking clumpy. Stars, galaxies, clusters, and starts looking smooth. We believe we have reached this scale, but if we could see past the horizon, we might find that our entire observable universe is just a single atom in a much larger structure of a hyper-universe. This fractal nature, where patterns repeat at different scales, could go on forever. We might be living inside an electron of a giant's world, and our 13.8 billion years of history is just a nanosecond flash in their reality. Theoretical physicist David Bohm proposed the holographic universe principle. It suggests that the 3D reality we experience is a projection from a 2D surface on the boundary of the universe. If this is true, then the unobservable horizon is actually the screen upon which our reality is written. We are holograms. The information describing you, your memories, and the Earth is encoded on the cosmic horizon. If that horizon is expanding, is the resolution of our reality changing? If it stops, do we freeze? We are data processing in a gravitational computer. The black hole information paradox connects directly to this. When things fall into a black hole, is the information lost? Stephen Hawking eventually said no, it's returned as radiation. But the universe itself has a horizon similar to a black hole. Are we inside a black hole? Some computations suggest that the density of our universe matches the density required to form a black hole of this size. We might be living inside the event horizon of a hypermassive star that collapsed in a parent universe. The Big Bang was the formation of the singularity. We are the interior of a monster. If we are inside a black hole, then the expansion of the universe is simply the growth of the black hole as it eats matter from the parent universe. Every time the parent black hole swallows a star, our universe expands. The dark energy is the influx of mass from the outside. This theory, cosmological natural selection, suggests universes reproduce through black holes. It frames our existence as a biological process of cosmic reproduction. We are the offspring of a dying star in a realm we can never see. But what if the process stops? What if the parent universe dies? Then our universe would starve. The expansion would stop, the cooling would begin. We are dependent on an umbilical cord connected to a mother universe that is completely unobservable to us. We are parasites in the belly of a beast, blind to the world outside the womb. It is a humbling and terrifying thought that our destiny is tied to events in a dimension we cannot access. The sheer number of galaxies we can see, 2 trillion, is overwhelming, but the number of galaxies we can't see is likely infinite. In an infinite universe, there is an infinite number of planets, exactly like Earth. There is an infinite number of planets where the dinosaurs didn't die. There is an infinite number of planets where you made different choices. This destroys the concept of uniqueness. You are not unique, you are an iteration, a repeating pattern in the wallpaper of infinity. The unobservable universe is the hall of mirrors where your duplicates live. Yet, we are trapped here. The tyranny of the rocket equation limits our travel. The tyranny of light speed limits our vision. We are localized creatures dreaming of the universal. The tragedy of humanity is that we have evolved the intelligence to deduce the existence of the infinite, but we possess the physical limitations that keep us imprisoned in the finite. We are gods chained to a rock, watching the eagles of entropy circle overhead. As we reach the midpoint of our investigation, the picture is clear. The standard model is a candlelight in a hurricane. It works for the small lit room we live in, but it fails to explain the howling winds outside, the dark flow, the cold spot, the Hubble tension, vacuum decay. These are the sounds of the storm battering our shelter. We are trying to hold the door shut with mathematics, but the hinges are starting to buckle. We have looked at the walls of our prison. Now we must look at the jailers. In the next stage of our journey, we will explore the specific, catastrophic ways the unobservable universe could end us. We will move from the theoretical to the visceral. We will ask, what happens when the walls come down? What happens when the silence breaks? The reality is not just that we are alone, it's that we are unprotected. To comprehend the ultimate fate that awaits us, we must bow before the tyrant of physics, entropy. The second law of thermodynamics states that the total entropy, the disorder, of an isolated system can never decrease over time. It implies that the universe is slowly winding down, moving from a state of order and high energy to a state of chaos and cold equilibrium. But here lies the terrifying question involving the unobservable. Is our observable universe an isolated system? If we are interacting with a larger multiverse, or if energy is leaking in or out of our bubble, then the laws of thermodynamics as we know them might be a local illusion. However, if the observable universe is indeed a closed box, then we are trapped in a slow-motion car crash. Every star that burns is increasing the entropy of the cosmos. Every thought you have, every breath you take, contributes to the heat death of the universe. We are engines of destruction, converting useful energy into useless heat, marching inevitably toward a time when no work can ever be done again. The clock was wound up at the Big Bang by a hand we cannot see, and it is ticking down to a midnight we cannot escape. The most accepted theory for the end of the universe is the heat death, or the Big Freeze. This is the direct consequence of the expansion of the universe accelerating into the unobservable. As galaxies are pulled apart faster than light, the supply of gas needed to form new stars becomes isolated and eventually exhausted. The era of starlight, the stelliferous era in which we currently live, is a brief, sparkling anomaly in an eternity of darkness. Eventually, the last star will be born, it will burn through its fuel, and it will die. The lights will go out, one by one. The universe will be populated by the corpses of stars, white dwarfs, neutron stars, and black holes. But even these will not last. White dwarfs will fade into black dwarfs, cold, dark balls of degenerate matter that emit no light. These objects have never been observed because the universe is not yet old enough for them to form. We are predicting the existence of ghosts that will haunt the dark long after humanity is forgotten. The unobservable future is a graveyard of frozen suns. But the horror deepens with the concept of proton decay. In the Standard Model, protons are stable, but in grand unified theories, GATs, which attempt to unite the fundamental forces, protons eventually decay into lighter subatomic particles. If this is true, then matter itself is not eternal. In the deep future, roughly 10 to the power of 34 years from now, the very atoms that make up the black dwarfs and the planets will begin to dissolve. The stuff of the universe will rot. Imagine a universe where not only the lights have gone out, but the walls are crumbling into dust. The solid ground of reality will liquefy into a bath of radiation. This is the ultimate victory of the void. The unobservable universe will eventually contain nothing but photons and leptons, a dilute soup of particles stretching across an infinite, expanding nothingness. It is a nihilistic masterpiece, a painting that slowly erases itself until the canvas is blank. After the decay of matter, only the black holes will remain. They will be the lords of the empty cosmos, reigning over domains of absolute darkness. But even they are mortal. Stephen Hawking showed that black holes emit radiation, Hawking radiation, and slowly lose mass over eons. The massive, supermassive black holes at the centers of galaxies will take a Google 10 to the power of 100 years to evaporate, but they will evaporate. As they die, they will flash out of existence in a final explosion of energy, illuminating the dark for a split second before vanishing forever. This is the black hole era of the future. It is a timeline so long that the entire history of humanity, from the first stone tool to the last spaceship, is less than a femtosecond in comparison. We are a flicker of a match in an endless, dark cavern, and we are terrified because we know the flame is consuming the wood. The unobservable future renders the present moment mathematically insignificant. There is, however, a violent alternative to this slow freezing death, the Big Rip. This scenario depends entirely on the nature of dark energy, the invisible force pushing the unobservable universe away from us. If dark energy is phantom energy, meaning its energy density increases as the universe expands, then the fabric of space-time will eventually be torn apart. The expansion will become infinite in a finite amount of time. First, the galaxies will be stripped away, then the solar systems, then the planets, and finally, in the last fraction of a second, the expansion speed will overcome the electromagnetic force holding your molecules together. You will be ripped apart at the atomic level. Space itself will be shredded. This is a violent, screeching end to reality, a singularity of expansion, where the laws of physics simply give up. The scariest part? We cannot measure the equation of state of dark energy precisely enough to rule this out. The mechanism for our execution is hiding in the decimal points of the data. We must also consider the Big Crunch, though it is currently out of favor due to the discovery of acceleration. However, if the unobservable universe contains vast amounts of matter or a different form of dark energy that eventually reverses, the expansion could stop. Gravity would win. The universe would begin to contract. The blue-shifted galaxies would rush back toward us. The temperature of the cosmos would rise as the background radiation is compressed. Eventually, the sky would become as hot as the surface of the sun. We would be cooked alive in a contracting oven. All matter would eventually crunch back into a singularity, a big crunch. Some theorists believe this leads to a big bounce, creating a new universe. If so, we are trapped in an eternal cycle of expanding and collapsing, dying and being reborn, with no memory of the previous iterations. It is a hell loop of cosmic proportions, a prison of eternal recurrence where escape is physically impossible. Let us look at the geometry of the universe, a secret held by the unobservable. Einstein's general relativity allows for space to be flat, positively curved like a sphere, or negatively curved like a saddle. Our measurements of the cosmic microwave background suggest the universe is flat within a 0.4% margin of error. A flat universe is likely infinite. But if it is slightly curved, just beyond the precision of our instruments, then the universe is a closed sphere. If you traveled far enough in a straight line, past the horizon, past the unobservable, you would eventually return to your starting point. You would see the back of your own head. This closed universe implies that the cosmos is a finite hall of mirrors. It is not an endless ocean, it is a small room, and we are just walking in circles. The illusion of infinity is created by the limit of light speed, hiding the back wall of our cell. The mystery of antimatter is another clue that the unobservable universe is hiding something massive. In the Big Bang, matter and antimatter should have been created in equal amounts. When they meet, they annihilate. If they were equal, the universe would be nothing but light. But we are here. There is more matter than antimatter. Where did the antimatter go? This is the baryon asymmetry problem. One terrifying possibility is that the antimatter didn't disappear. It was simply separated. There could be vast regions of the unobservable universe that are made entirely of antimatter. Anti-galaxies composed of anti-stars, burning anti-hydrogen. They would look exactly like normal galaxies through a telescope. But if our region of the universe ever collided with an antimatter region, the boundary would be a wall of pure annihilation energy. We could be drifting toward an invisible minefield that will erase us upon contact. What lies between the galaxies and the unobservable void? We assume it is a vacuum, but quantum mechanics tells us that a vacuum is never truly empty. It is a seething foam of virtual particles popping in and out of existence. This is the quantum foam. At the Planck scale, the smallest possible unit of space, reality is not smooth. It is a chaotic, boiling turbulence of changing topology. Space-time itself might be dissolving and reforming constantly. If the energy of this vacuum, the zero-point energy, could be tapped, a coffee cup of empty space would contain enough energy to boil all the oceans on Earth. The unobservable universe is not a quiet, empty room. It is a roaring ocean of infinite power, and we are floating on the surface, unaware of the depth. The fact that this energy doesn't collapse the universe into a black hole instantly is one of the biggest unsolved problems in physics, the cosmological constant problem. The numbers are off by a factor of 10 to the power of 120. We are missing something fundamental about the nature of nothingness. Consider the CPT symmetry hypothesis regarding the Big Bang. Physics generally obeys Kaplan symmetry: charge, parity, time. Some theorists, like Neil Turok, propose that for the Big Bang to preserve this symmetry, it must have created two universes. One is ours. The other is a mirror universe, expanding in the opposite direction of time, dominated by antimatter. In that universe, time runs backward relative to us. It is a Benjamin Button reality, moving away from the Big Bang into the past. This mirror universe would be unobservable by definition, yet it is the twin of our reality. It balances the cosmic ledger. Are there mirror versions of us in the antiverse, living lives in reverse? Or is it a chaotic wasteland? The idea that our reality is only half of the equation, the front of the coin, is a haunting reminder of dualism in nature. We are incomplete. The Great Wall structures challenge the very laws of probability. We have discovered the Hercules Corona Borealis Great Wall. a superstructure of galaxies measuring 10 billion light-years across. It is so large that light takes 10 billion years to cross it. Since the universe is only 13.8 billion years old, this structure shouldn't exist. There simply hasn't been enough time since the Big Bang for gravity to pull this much matter together into such a colossal shape. It violates the cosmological limit on size. This suggests that this structure was not formed by standard gravity but was seeded by something prior to the Big Bang, or by forces acting from the unobservable universe. It is a fossil of a pre-universal epoch. We are looking at the skeletal remains of a beast that died before time began, and its bones are the scaffolding of our galaxy. Let us reconsider the dark fluid theory. Instead of dark matter and dark energy being two separate mysteries, some physicists propose they are effects of a single dark fluid that fills the universe. This fluid behaves like matter on small scales, holding galaxies together, and like dark energy on large scales, pushing the universe apart. If this is true, we are like fish swimming in water, unaware of the medium we move through. The unobservable isn't far away. It is the medium itself. We are waving our hands through a substance that dictates our movements, yet remains invisible to our senses. The universe is not empty space with stuff in it. It is a dense ocean, and we are merely the debris floating in the current. The ripples in this fluid could explain the weird motions of the dark flow. We are caught in a riptide of an exotic liquid we cannot touch. The neutrino background offers a ghostly window into the unobservable. Neutrinos are subatomic particles that barely interact with matter. They pass through the Earth and your body by the trillions every second. There is a cosmic neutrino background, C and B, similar to the microwave background, but released just 1 second after the Big Bang. If we could build a detector sensitive enough to see it, we would see the universe as it was almost at the moment of creation. But neutrinos can also travel from unobservable regions without being blocked. They are messengers from the deep. A supernova in a galaxy beyond our horizon sends neutrinos that reach us, while its light never will. We are being bathed in information from the unobservable universe, but we are deaf to the language. The secrets of the deep cosmos are passing right through our fingertips, and we lack the technology to catch them. Gravitational waves have opened a new sense for humanity. We can now hear the universe. When two black holes collide, they ripple the fabric of space-time. These ripples travel at the speed of light. But what if we detect a gravitational wave background that is too loud? This stochastic gravitational wave background could be the hum of millions of collisions happening in the unobservable universe. Or it could be the rumbling of cosmic strings. Cosmic strings are hypothetical one-dimensional defects in space-time, thinner than a proton but with the mass of a continent. If they exist, they are whipping through the universe at light speed, snapping and vibrating. If a cosmic string passed through Earth, it would slice the planet in half like a hot knife through butter. They are invisible whips thrashing in the dark, remnants of the violent cooling of the early universe. The fine-tuning problem serves as a philosophical anchor for the multiverse. The fundamental constants of physics, the strength of gravity, the charge of the electron, the cosmological constant, seem perfectly calibrated to allow life. If the strong nuclear force were 2% stronger, stars would burn out in seconds. If it were 2% weaker, no elements heavier than hydrogen would form. The odds of this happening by chance are astronomical. 1 in 10 to the power of 229. There are two options. Either we were designed, or there are an infinite number of unobservable universes where the numbers are wrong and life is impossible. We are the winners of a cosmic lottery. But this implies a cosmic graveyard of trillions of failed universes, sterile and broken, filling the bulk of the multiverse. We are standing on a pile of corpses, celebrating our luck. The unobservable is a wasteland of failed physics. Let us discuss the psychological impact of the unobservable. It forces us to confront cosmic nihilism. If the universe is infinite, then nothing we do matters on a grand scale. If there are infinite versions of you, then your choices are meaningless, because every choice is made somewhere. If the universe is destined for heat death, then all achievements of civilization will be erased. This is not just a philosophical problem. It is a barrier to our evolution. Why expand? Why explore? The unobservable universe imposes a ceiling on our ambition by rendering our legacy temporary. However, the counter-argument is cosmic defiance. We create meaning because the universe provides none. We light a fire in the void because it is cold. The existence of the unobservable darkness gives value to our observable light. We are the rebellion against the entropy of the dark. We must consider the zoo hypothesis in relation to the unobservable. Perhaps advanced civilizations have not just colonized galaxies, but have moved beyond the observable universe or into the bulk of higher dimensions. They might view our 3D, expanding bubble as a nature preserve or a quarantine zone. We are the primitive species stuck in the slow zone of the universe, while the adults operate in the unobservable realms of hyperspace or quantum-locked regions. The silence of the sky is the silence of a spectator behind one-way glass. They are watching us, but they are strictly forbidden from tapping on the glass. We are the exhibit. The unobservable universe is the viewing gallery. The concept of time dilation near the horizon is another mind-bending reality. As we look deeper into space, we look back in time. But at the event horizon of a black hole, time stops from the perspective of an outside observer. The cosmic horizon has similar properties. If we could watch an object cross the horizon, which we can't, but hypothetically, its light would redshift until it froze. It would fade into the infrared, then radio, then silence. It would never truly disappear. It would just become a ghostly, frozen image pasted on the sky. The edge of the universe is a museum of frozen moments, a collection of things that have left us, but can never truly say goodbye. We are surrounded by the lingering ghosts of galaxies that have long since fled into the dark. Is the universe a strange loop? Physicist John Wheeler proposed the participatory anthropic principle, that the universe does not exist unless there is an observer to collapse the wave function. It from bit. This implies that by looking at the cosmic microwave background, we are actually creating the Big Bang retrospectively. We are the eye of the universe looking at itself. But this creates a paradox for the unobservable. If no one is observing the regions past the horizon, do they exist? Or is the unobservable universe in a state of undefined probability, waiting for an observer that will never arrive? It might be that the universe is only as large as the light that has reached a conscious mind. Beyond that edge, there is literally nothing, not even space, until an eye opens to see it. The axis of evil anomaly we mentioned earlier has a companion, the parity violation. The universe seems to prefer left-handed orientations in the spiral of galaxies and the spin of particles. Why? In a symmetrical Big Bang, there should be no preference. This handedness suggests the universe was rotating when it was born. If the entire universe is spinning, it has an axis. It has a north and south pole. But spinning relative to what? Rotation requires an external frame of reference. This implies the existence of an outside. The unobservable universe isn't just more space. It is the room in which our universe is spinning like a top. We are dizzy from a motion we cannot feel, spinning in a void we cannot see. We are currently in the era of precision cosmology, but we might be approaching the era of limit. We are hitting the hard walls of what is knowable. The opacity of the early universe, before the CMB, prevents us from seeing the first 380,000 years with light. We are blind to our own birth. We rely on gravitational waves and neutrinos to pierce this veil, but even they have limits. The inflationary wall erases information. Cosmic inflation stretches space so much that the initial conditions of the universe are smoothed out and lost forever. We can never know what the universe looked like before inflation. The unobservable universe has scrubbed the crime scene clean. We are detectives arriving a billion years too late with no fingerprints to find. The trans-Planckian problem in black hole physics also applies to cosmology. If we trace the expansion of the universe back far enough, the wavelengths of light we see today were once smaller than the Planck length, the smallest possible unit of size. Physics breaks down below the Planck length. This means the light we use to map the cosmos originated from a realm where our laws of physics do not apply. We are building a map of the galaxy based on signals that emerged from a, quote, physics-less state. It suggests that the foundation of our reality is built on a glitch, a singularity where math fails. The unobservable isn't just far away, it is too small, yet it grew to become the sky. The macroscopic monster was born from the microscopic ghost. Let's revisit the cold spot with a new lens, the supervoid. If it is a void, it is the largest thing in existence. A bubble of nothing, 1.8 billion light-years across. How does a bubble of nothing grow that big? It pushes matter away. It is a repulsive zone. Imagine living on a planet inside the supervoid. The night sky would be pitch black. No stars. No Milky Way. Just absolute suffocating darkness. You would have no concept of astronomy. You would think the universe was empty. There could be civilizations trapped in the center of that void right now, thinking they are the only matter in existence, while we look at their home from the outside and see it as a cold scar. Perspective is everything. Our observable universe is someone else's unobservable void. The dipole repeller pushes us, and the Shapley attractor pulls us. This creates a bulk flow. We are flowing like water in a river. But where does the river end? All rivers eventually reach the ocean. Is there a cosmic ocean, where all matter eventually collects? A region of maximum density, where galaxies congregate to die? If so, it is likely beyond the horizon. We are merely in the tributaries, drifting downstream. We can feel the current, but we cannot see the waterfall. The unobservable universe might be a gravitational drain that swallows entire superclusters, compressing them into a hyperdense state that eventually ignites the next Big Bang. We are just logs floating toward the saw blade. What if the speed of light is decaying? The variable speed of light VSL theory suggests that in the early universe, light was much faster, infinite perhaps. This would solve the horizon problem without inflation. But if light is slowing down, then the horizon is shrinking faster than we think. It implies the fundamental constants are aging, the universe is getting sluggish. Like an old engine, the reaction times are slowing down. If c, the speed of light, drops, our connectivity to the universe drops. We become more isolated. The unobservable universe grows as the speed of information slows. We are freezing in place, unable to reach out, as the nerves of the cosmos deaden. The Eridanus supervoid, linked to the cold spot, is not the only anomaly. There are hotspots too, regions of the CMB that are statistically too energetic. These could be evaporating black holes from a previous universe, or white holes spewing matter into ours. A white hole is the theoretical reverse of a black hole. Nothing can enter, only exit. Are we seeing the exhaust ports of the unobservable universe? Is matter being pumped into our reality from elsewhere? If so, the conservation of energy is a lie, or at least limited to our bubble. We might be the landfill of the multiverse, where other universes dump their excess entropy and matter. We are the cosmic trash can. The WOW signal detected in 1977 remains the strongest candidate for extraterrestrial contact. It was a narrow-band radio signal, distinct and powerful from the constellation Sagittarius. It lasted 72 seconds and never repeated. Why? Maybe the source moved behind the unobservable horizon. Or maybe it was a sweeping signal, like a lighthouse beam, and the rotation of the source means it won't hit Earth again for 1,000,000 years. Or, darker still, maybe the source was destroyed. Maybe the silence that followed was the silence of extinction. We heard the last scream of a dying world before the unobservable threat consumed them. We are listening to the echoes of the dead. The universe is expanding, but is it rotating? Kurt Gödel found a solution to Einstein's equations describing a rotating universe. In such a universe, closed time-like curves exist. Time travel would be possible. You could travel into your own past by moving in a large enough circle. While observation suggests no rotation, the axis of evil hints otherwise. If the universe is rotating, the unobservable regions are the wings of the carousel. The centrifugal force would be tearing the outer edges apart. We might be in the calm eye of a spinning storm, unaware that the periphery is being shredded by the rotation of reality itself. Time travel might be possible out there, in the chaotic zones we can never reach. We tend to think of the Big Bang as a point in the past. But in an infinite universe, the Big Bang is happening somewhere right now. If the universe creates pocket universes through eternal inflation, then new Big Bangs are going off like popcorn in the unobservable bulk. We are just one pop. Somewhere, far beyond the reach of light, a new universe is being born this very second. New laws of physics are crystallizing. New stars are igniting. We are the old guard, the ancient, cooling embers of a previous explosion, while the fireworks continue without us. We are not the center of the show. We are the debris in the parking lot. The dark ages of the universe, the period between the Big Bang and the first stars, lasted hundreds of millions of years. It was opaque and neutral. We are trying to peer through this fog with radio astronomy, the 21 centimeters line. We want to see the cosmic dawn. But what if the fog is hiding something? What if the first stars were not stars as we know them, but dark stars, powered by dark matter annihilation? These giants would be invisible to optical telescopes, but massive enough to seed the supermassive black holes we see today. The unobservable history of the universe is a shadow play of monsters that grew in the dark, setting the stage for the tragedy of the galaxies. We are living in the house they built. Let's talk about rogue planets. Astronomers estimate there are billions of rogue planets in the Milky Way alone, planets ejected from their solar systems, drifting in the frozen dark. Now scale that up to the unobservable universe. There are quintillions of rogue planets drifting in the intergalactic voids. Worlds of ice, worlds of rock, possibly worlds with subsurface oceans and life clinging to volcanic vents in the core. These are the orphan worlds. They will never see a sun. They will never know a year. They drift in eternal night. If the universe is infinite, there is a rogue Earth out there, an exact copy of our planet, but frozen solid, drifting in the black, a dead twin in the dark. The Kardashev scale categorizes civilizations by energy use. Type 1 uses a planet, Type 2 a star, Type 3 a galaxy. But what about Type 4? A civilization that controls the energy of the observable universe. And Type 5? One that controls the unobservable multiverse. If such beings exist, they are indistinguishable from gods. They could manipulate the laws of physics. They could be the ones accelerating the expansion. They could be the reason the vacuum is stable. We look for aliens with radio dishes, but a Type 5 civilization wouldn't use radio. They would move galaxies like chess pieces. The anomalies we see, the dark flow, the cold spot, might not be natural. They might be engineering projects. We are ants wondering why the sidewalk is vibrating, unaware of the construction crew next door. The great attractor is pulling us, but the expansion is pushing us away. Eventually the push will win. The gravitational bonds will snap. The Laniakea supercluster will dissolve. We will never reach the great attractor. It is a destination we are traveling toward at millions of miles per hour, yet we will never arrive. It is a cosmic Tantalus torture. We are doomed to chase a phantom until the road itself disintegrates beneath our feet. The unobservable universe is full of destinations that are physically impossible to reach, teasing us with their gravity before vanishing behind the horizon of expansion. There is a hypothesis called panpsychism, that consciousness is a fundamental property of matter, like mass or charge. If this is true, then the universe itself is conscious. The complex web of galaxies, connected by filaments of dark matter, resembles the neural network of a brain. The unobservable universe is the rest of the brain. We are just one thought in a cosmic mind. Is the universe thinking? Is it dreaming? Are we the nightmare? If the universe is waking up, the Great Awakening might look like the end of the world to us. We are the bacteria in the synapse, terrified of the electrical impulse. The arrow of time points forward because of entropy. But in the unobservable vastness, could there be regions where the arrow points backward or sideways? Time might not be a universal constant. In the bulk of string theory, time might be a spatial dimension you can walk through. If so, the past is not gone. It is just over there. The unobservable universe contains all of history, preserved in a block universe. Your birth, your death, and this moment are all existing simultaneously in the 4D structure of the cosmos. We are simply a spotlight moving across a static stage. The horror is that the script is already written, and we are just reciting our lines. We are made of stardust, but we are also made of the Big Bang. The hydrogen in the water in your body was formed 13.8 billion years ago. You are an ancient creature, But the heavy elements, the gold, the lead, were forged in neutron star collisions. These collisions are rare. We are the result of a violent, lucky chain of events in the observable sector. In the unobservable universe, there might be vast regions where the metallicity is too low for life. No carbon, no oxygen, no iron, just endless, sterile clouds of hydrogen gas. We are the metal-rich anomaly. Life is a rust on the surface of a dead universe. The Fermi paradox again. Maybe the aliens aren't in the unobservable universe. Maybe they left the universe. If a civilization becomes advanced enough, they might realize this universe is a dying trap, entropy, expansion. They might punch a hole in the vacuum, a baby universe, and escape into it. They effectively leave the server. The silence of the sky is because everyone else found the exit door. We are the ones left behind in the burning building, too stupid to find the fire escape. The unobservable universe is the path they took, leaving us with the empty shell. Let us consider the Boltzmann brain again, but as a Boltzmann universe. It is statistically more likely for our universe to be a random fluctuation that looks like it has a past, than for it to actually have a past. This means the fossils in the ground, the light from the stars, and your memories might be fake, instantiated this very second by a random roll of the quantum dice. If this is true, the unobservable universe doesn't exist. There is only this bubble, right now, and it will pop in a moment. The horizon is the edge of the simulation's render distance. We are living in a solipsistic nightmare, where nothing outside our immediate perception is real. The void is growing. The expansion of the universe is essentially the creation of more void. The unobservable universe is mostly empty space. We treasure the galaxies, the lights, the matter. But the universe treasures the nothingness. It creates more of it every second. We are fighting a losing battle against the void. Eventually, the voids will merge. The galaxies will be islands in an ocean so vast that light will die before crossing it. We are the last holdouts of existence, huddled around a dying fire, while the winter of non-existence lengthens the night. The ultimate state of the universe is not fire, but silence. Dark matter holds the galaxies together. Without it, the Milky Way would fly apart. We owe our existence to a ghost. We are living in a scaffold made of invisible material. But what if dark matter is unstable? What if it decays? If the dark matter in the unobservable universe starts to decay into radiation, the gravity holding the galaxies together will vanish. The galaxies will unwind. Stars will be flung into the dark. We depend on the stability of a substance we have never seen and do not understand. We are building our house on a foundation of invisible ice, and we don't know if it's melting. The observable universe is a sphere centered on you. Every person has their own observable universe. If you move a light year to the right, you see a light year further to the right. This means the edge is subjective. It is a personal horizon. We each live in our own private reality tunnel, but all our tunnels overlap. We share the illusion. However, an observer 46 billion light-years away sees a completely different universe, with different galaxies and a different destiny. We are disconnected not just by distance, but by the very definition of reality. To them, we are the unobservable ghosts at the edge of their map. The cosmic web is the largest structure we know, but simulations show that the distribution of dark matter looks like a sponge. There are tunnels and caverns in the dark matter. Are we inside a tunnel? The unobservable universe might be the solid rock of the sponge, and we are the moss growing in the damp cave. We haven't seen the outside of the structure. We don't know if the sponge is sitting in an ocean or drying in the sun. We are microscopic organisms speculating on the geography of a continent we can never visit. Quintessence is a dynamic form of dark energy that changes over time. If quintessence exists, the fate of the universe is not sealed. It could switch from repulsion to attraction. The big rip could become a big crunch. The unobservable universe holds the switch. If a phase transition occurs in the quintessence field a trillion light-years away, a wave of new physics travels toward us. We are waiting for a weather report that will tell us if we are going to freeze or burn, but the weatherman is dead. The uncertainty is the only certainty. The Heisenberg uncertainty principle puts a limit on what we can know about particles. The cosmic horizon puts a limit on what we can know about the universe. There seems to be a censorship built into reality. Nature hates naked singularities and hates absolute knowledge. It hides the core of black holes and the edge of the cosmos. Why? Is knowledge dangerous? Does observing the system break the system? Perhaps the unobservable universe remains unobservable for our own protection. If we saw what was out there, our reality might collapse under the weight of the truth. We use the redshift of light to measure speed. But what if the tired light hypothesis is partially true? What if light gets tired over billions of years? It would mean the universe isn't expanding as fast as we think. It would mean the unobservable universe is closer than we fear. But it would also mean that general relativity is wrong. We have to choose between a terrifyingly expanding universe or a terrifyingly broken law of physics. Both roads lead to a crisis in our understanding of reality. The unobservable holds the answer key, but it refuses to show us the paper. Supersymmetry predicts that every particle has a superpartner. We haven't found them. Maybe they are too heavy. Or maybe they exist in the unobservable universe. Maybe the symmetry is broken in our bubble but restored out there. A symmetric universe would look completely different, crystalline, perfect, static. We might be the broken shard, the ugly, chaotic, asymmetrical fragment of a beautiful whole. We are the mistake that allowed life to happen. The unobservable perfection is lethal to us. The mass of the neutrino is a mystery. If it is too heavy, the universe collapses. If it is too light, it expands forever. We are trying to weigh a ghost particle to determine the fate of all existence. The unobservable universe is filled with these particles. Their collective mass is the ballast in the ship of the cosmos. We are trying to steer the ship without knowing how much cargo we are carrying. We are sailing blind into a storm, hoping the hull holds together. The lithium problem. The Big Bang Theory predicts a certain amount of lithium-7. We see only a third of that. Where is the missing lithium? Did it leak into the unobservable? Or is our theory of the first 3 minutes of the universe flawed? This missing matter is a breadcrumb trail leading off the edge of the map. It hints that the oven of the Big Bang had a leak. Something took our lithium. Something outside. We are carbon-based life forms. Carbon requires triple alpha process in stars. It requires fine-tuning. In the vast unobservable multiverse, there could be silicon-based life, or plasma-based life, or life forms made of pure information encoded in the spin of electrons. We are looking for water and oxygen, but the universe might be teeming with weird life that we wouldn't even recognize as alive. We could be looking right at them, in the plasma of a star, in the dust of a nebula, and seeing only dead matter. The unobservable isn't just distance, it's a failure of imagination. As we close the book on the implications, we realize that the observable universe is a misnomer. It should be called the permissible universe, the part we are allowed to see. The bars of the cage are made of light speed and time. But cages are not just for keeping things in, they are for keeping things out. What is the horizon keeping out? In the final leg of our journey, we will look at the philosophical and emotional cost of this isolation. We will ask the question, is it better not to know? We stand at the precipice of understanding, looking out into the black, and we realize that our entire history is a localized phenomenon. The Great Filter might not be a single event, but a continuous pressure from the unobservable. Imagine a universe where the laws of physics are hostile to complexity, constantly trying to unravel DNA and smash atoms. We are fighting a guerrilla war against a universe that wants us to be simple hydrogen gas. The unobservable void is the enemy territory, and every day we survive is an act of defiance against the natural order of decay. We are the resistance. The concept of cosmic horror relies on the unknown. But what if the unknown is actually unknowable? Gödel's incompleteness theorems suggest that in any logical system there are truths that cannot be proven. The universe is a system. Therefore, there are truths about the cosmos that we can never, ever prove. The nature of the unobservable universe might be one of these undecidable propositions. We are physically incapable of knowing the answer. It is not a puzzle waiting to be solved. It is a locked door with no keyhole. We are banging our fists against a wall that was built to never be breached. Let's reconsider the dark flow one last time. If we are flowing toward a massive structure, and that structure is a great attractor on steroids, what happens when we get there? Do we merge with it? Do we crash? Or do we orbit it forever? If it is a super cluster, it might be the capital city of our local universe. A region so dense with galaxies that the night sky is a blinding wall of white light. Life there would be very different. They wouldn't know the dark. They wouldn't know isolation. They would be the core worlds. And we are the savages in the outer rim, drifting in the dark, cold, lonely expanse. Spooky action at a distance. Quantum entanglement. If two particles are entangled, they share a state. If one falls past the cosmic horizon and we measure the one here, do we instantly affect the one out there? Does the connection break? If it holds, then the universe is non-local. The unobservable is connected to us by invisible threads of quantum information. We might be puppets dancing on strings, pulled by a hand a billion light years away. We think we have free will, but our atoms are entangled with a cloud of gas in a galaxy we will never see. Our destiny is written in the stars, the invisible ones. The Copernican principle says we are not special, but the anthropic principle says we must be special enough to exist. This tension defines our relationship with the unobservable. If the multiverse is real, then mediocrity is the rule. We are average. But if the universe is finite and we are the only life, then we are infinitely precious. The unobservable holds the vote. If it is empty, we are kings. If it is full, we are peasants. We are waiting for the election results. But the ballot box is sealed in a concrete bunker 46 billion light years away. Entropy is the arrow of time. But near a black hole, time slows. Inside a black hole, space and time swap roles. You move through time like you move through space. In the unobservable universe, if the density is high enough, space-time could be a knotted mess. Time could loop, branch, or stop. There could be regions of timelessness. Civilizations there wouldn't have history. They would live in an eternal moment. We are slaves to the clock, marching toward death, while they float in the amber of eternity. The unobservable might be the land of the immortals, guarded by the wall of light speed. The simulation hypothesis again. If we are in a simulation, the horizon is a way to save processing power. Procedural generation. The computer only renders what you look at. When you look deep into space, the computer quickly generates a galaxy. Here, have a galaxy. This explains why the universe looks the same everywhere, homogeneity. It is reusing assets. The dark flow is a glitch in the physics engine. The cold spot is a corrupted texture file. We are looking for meaning in a video game code, mistaking bugs for features. The unobservable is simply null. It hasn't been coded yet. Panspermia, the idea that life came from space. Comets carrying bacteria. If the universe is infinite, life could have started 1 trillion years ago in the unobservable regions and spread here. We might be an invasive species. We might be the descendants of a biological weapon fired across the cosmos. Or we might be the refugees of a dying world, carried on a rock across the void. Our DNA might contain the map to a home we can no longer see. We are orphans looking for a mother who vanished behind the horizon eons ago. The great silence is deafening. We send radio waves, we listen. Nothing. Maybe the unobservable universe is loud. Maybe the radio waves from distant civilizations effectively form a background hum that we mistake for static. The cosmic microwave background might be the overlapping signals of quadrillions of dead civilizations, blurred by redshift into a single tone. We are listening to the voices of the dead and calling it radiation. The static on your old TV is the scream of the universe. The dark forest theory suggests that civilizations hide because there are predators. If the unobservable universe is a dark forest, then the horizon is our tree line. We are clearing the forest, lighting fires, shouting, "We are here!" We are the noisy campers. The predators in the deep woods haven't noticed us yet, or maybe they have. Maybe the dark flow is them coming to investigate the noise. The silence isn't peace, it's an ambush. Vacuum energy. The energy of nothing. If we could extract it, we would be gods. But if we poke it too hard, we might trigger vacuum decay. It is a booby trap. The ultimate power source is also a self-destruct button. The unobservable universe might be littered with craters where civilizations tried to tap the zero-point energy and blew themselves up. We are the monkeys playing with a hand grenade, wondering why the pin is so shiny. The unobservable history is a lesson in hubris written in explosions. Black hole cosmology. If our universe is the interior of a black hole, then the Big Bang was the collapse of the parent star. The singularity is our future, or past. But what is outside the black hole? A parent universe with different laws. Maybe 5 dimensions. Maybe 10. We are the internal organs of a cosmic beast. Does the beast get sick? Does it die? If the parent black hole evaporates via Hawking radiation, our universe disappears. We are slowly evaporating. We are fading away. The unobservable outside determines our lifespan. Eternal inflation creates a fractal multiverse, bubbles within bubbles. If this is true, then the laws of physics are local bylaws, not a constitution. In the unobservable, gravity might be repulsive. Light might be solid. Time might be circular. We are studying the rules of our specific village and thinking they apply to the whole empire. They don't. We are provincial yokels in a cosmopolitan cosmos, shocked by the customs of the capital. The unobservable is the Wild West of physics. Cosmic strings again? If they form a network, they could act as rails for movement. A civilization could ride a cosmic string across the universe, but strings have immense tension. If a string snaps, the energy release would be cataclysmic. A string break in the unobservable universe would send a shockwave of gravitational waves that could shatter planets. We detect gravitational wave bursts. Are these the sounds of snapping cables? Is the elevator of the universe falling? The doomsday argument, a statistical argument that suggests you are likely to be born in the middle of humanity's timeline, not the beginning. If there are 100 billion humans so far, and we are in the middle, then humanity will end after another 100 billion. It predicts our extinction is near. But if the universe is infinite, the reference class is infinite. The math breaks. The unobservable universe saves us from the doomsday argument by making the sample size infinite. Or does it? If we are the only ones, the clock is ticking. The unobservable is either our savior or our judge. Bolshoi simulation. Massive supercomputer simulations of the universe's structure. They match our observations. But they assume cold dark matter. If dark matter is fuzzy or warm, the structure changes. The unobservable universe is the testing ground for these theories. We can't see the small-scale structure deep in space. We are fitting the curve to the data points we have, but the curve might go wild off the chart. We are extrapolating stability from a small sample. It is like looking at a frozen lake and assuming the whole ocean is ice. Information conservation. Quantum mechanics says information cannot be destroyed. But the expansion of the universe moves galaxies past the horizon. The information is lost to us. Does it still exist? It violates our access to information. The universe is deleting files from our hard drive. We are losing our memory. Eventually, we will be senile. A civilization in the far future will have no record of the Big Bang. They will live in an eternal present, with no past and no future. We are the keepers of the lore, and the library is burning. Naked singularities. General relativity allows for singularities without an event horizon. Naked monsters. They would be visible. They would defy causality. You could see the future in them. The cosmic censorship hypothesis says they can't exist. But simulation suggests they can form in the collapse of oblong shapes. If a naked singularity exists in the unobservable universe, it is a hole in reality where anything can come out. Dragons, demons, paradoxes. It is a Pandora's box that physics tries to keep shut. But the box is out there. Variable constants. What if g, gravitational constant, is changing? If gravity was stronger in the past, the unobservable universe, which is the past, would look different. Stars would burn brighter and die faster. If gravity is getting weaker, the future is cold. The unobservable holds the history of the constants. We measure them here and now and assume they are everywhere and always. That is a leap of faith. The universe might be evolving. Physics might be evolving. We are taking a snapshot of a moving animal and calling it a statue. Tachyons, hypothetical particles that move faster than light. They travel backward in time. If they exist, they could carry messages from the unobservable universe. They could warn us of the vacuum decay. But we haven't found them. Are they impossible? Or are we just not listening on the right frequency? A tachyon telephone would connect us to the multiverse. But it would also break causality. You could kill your grandfather. The universe protects itself from paradoxes by silencing the tachyons. The unobservable remains mute to preserve sanity. White holes, mathematical opposites of black holes. They spew matter. They cannot be entered. Are quasars white holes? No, they are accretion disks. But maybe the Big Bang was a white hole? A momentary white hole. If white holes exist in the unobservable universe, they are fountains of creation. They are pouring new matter into reality. Continuous creation. This would counter the heat death. It offers hope. But we haven't seen one. The unobservable is stingy. It takes, but it doesn't give back. Mirror matter, not antimatter. Matter that doesn't interact with electromagnetism but has its own mirror electromagnetism, mirror stars, mirror planets, mirror life. They could be right here, we could pass through them. Gravity would be the only clue. Dark matter could be mirror matter. The unobservable universe is superimposed on ours. We are ghosting through a crowded room. We feel the gravity of the invisible guests, but we can't shake their hands. We are haunting each other. Modified gravity. MOND, an alternative to dark matter. It says gravity works differently on large scales. If MOND is true, there is no dark matter. The unobservable universe is governed by a different equation than the solar system. Newton was wrong on the galactic scale. Einstein was wrong on the cosmic scale. We are using the wrong map. The terrain of the unobservable universe is alien to our math. We are trying to navigate a mountain range with a subway map. We are going to get lost. Cosmic topologic defects, monopoles, textures, domain walls, flaws in the crystal of space-time. A domain wall is a sheet of energy separating two regions of different vacuum. If a domain wall sweeps through the galaxy, it changes the physics. It reboots the system. The unobservable universe might be a patchwork quilt of domains, separated by walls of fire. We are in one patch. We hope the walls hold. We hope the stitching doesn't rip. Eternity. The human mind cannot grasp it. We get bored, we die. But the universe doesn't. The unobservable universe forces us to confront deep time. 10 to the power of 100 years. The decay of protons. The evaporation of black holes. It is a timescale where life is a rounding error. We are a momentary flash of complexity in an ocean of entropy. The unobservable is the face of eternity, staring at us with a blank expression. It doesn't care, it just waits. Solipsism, the fear that only your mind exists. The unobservable universe is the ultimate solipsistic trap. Since you can never interact with it, does it exist? Quantum mechanics says, maybe not. Realism says yes. We are torn between philosophy and physics. The unobservable challenges our definition of reality. Is reality what we measure? Or is reality what is there? If we can't measure it, is it there? The tree falling in the forest with no one to hear it. The universe expanding in the dark with no one to see it. The Omphalos hypothesis, last Thursdayism. The universe was created last Thursday with the appearance of age. The light from distant galaxies was created in transit. It is a deception. The unobservable universe is a painted backdrop. Why? To test our faith. To mess with us? It makes science impossible. But it can't be disproven. The unobservable feeds this paranoia. We can't verify the deep past. We rely on the consistency of the story. But the story could be a lie. Observer effect. We change reality by measuring it. By looking at the CMB, we collapse the early universe into a specific history. We are retroactive creators. The unobservable universe is uncollapsed. It is a probability cloud. It is a haze of potential. It only becomes real when the horizon expands and we see it. We are the sculptors of reality, chiseling the statue of the universe out of the block of quantum foam with our telescopes. Existential risk. We worry about AI, nukes, asteroids. But the cosmic risk is non-zero. Vacuum decay, big rip, bolide from the dark. We can't mitigate it. We can't stop it. We can only watch. This helplessness is the core of the horror. We are passengers on a bus with no driver, speeding down a mountain at night. The unobservable is the cliff edge. We are just hoping the road goes on. Legacy. We want to leave a mark. We broadcast radio, we send voyagers. But the expansion erases our mark. The signals fade. The probes drift into the void. The unobservable universe swallows our scream. In the long run, it will be as if we never existed. The universe is a self-cleaning oven. It burns away the stains of life. Our struggle for immortality is a fight against the geometry of space-time itself. We are fighting the map. Fermi's paradox. The zoo hypothesis. Maybe the aliens are keeping us in a nature preserve. They block the signals from the unobservable universe. They create a fake quiet sky. We are in a Truman Show. The unobservable universe is the studio. The stars are stage lights. The dark flow is the director moving the set. We are actors in a play we didn't write, for an audience we can't see. Dark energy is constant. But what if it's not? Quintessence. It could be oscillating. The universe could be breathing, expanding and contracting. We are in an inhalation. The unobservable holds the rhythm. If it exhales, we crunch. We are living inside the lungs of a giant. We measure the expansion and think it's forever. But it might just be a breath. We are dust mites in the airway. Fine structure constant, alpha, controls electromagnetism. Evidence suggests it might vary across the universe. In the unobservable north, it's smaller. In the south, larger. If alpha changes, chemistry changes. Life is impossible. We are in the Goldilocks zone of alpha. The unobservable universe is a chemical wasteland where atoms can't bond. We are the oasis. The desert is infinite. Superdeterminism. Quantum loophole. Everything is predetermined. Free will is an illusion. The unobservable universe dictates our actions through hidden variables established at the Big Bang. We are clockwork toys. We think we are exploring, but we are running on rails. The unobservable is the gearbox. We are the hands of the clock, thinking we are moving the time. The great attractor again. Laniakea. Immeasurable heaven. It sounds poetic. But it's a gravity well. We are falling. The dipole repeller is pushing. We are being evicted from our home and dragged to a prison. The unobservable universe is a landscape of forces, not places. It is a dynamic, violent churning. We are debris in a storm surge. Cosmic censorship. Penrose. Singularities are hidden. Nature protects us from the chaos. But if the sensor fails, if the unobservable reveals a naked singularity, physics breaks. Predictability ends. We live in a rational universe only because the irrational parts are hidden. The unobservable is the asylum where the crazy physics is locked up. We hope the locks hold. Holographic principle. We are 2D information on a 3D horizon. The bulk is the true reality. We are the shadow. The unobservable universe is the object casting the shadow. We are studying the shadow on the wall of the cave. Plato. We can never turn around to see the fire. We can never see the true forms. We are trapped in the projection. Quantum suicide. Multiverse theory. If you die in this universe, you survive in another. Consciousness moves to the surviving branch. You are immortal in your own subjective experience. But the unobservable universe is full of your corpses. For every version of you that survives, trillions die. You are walking on a path of your own dead bodies. The unobservable is a graveyard of your failures. Boltzmann brain statistics. The longer the universe lasts, the more likely they are. In the heat death, they will dominate. The future unobservable universe will be populated by hallucinations. Lonely minds floating in the dark, dreaming of Earth. We are the ancestors of madness. We are the last sane generation. before the asylum opens. The big snap. If space is granular, discrete, the expansion might snap the grid, like stretching a rubber band until it breaks. Space itself would fracture, no travel, no light. The unobservable universe would shatter into disconnected shards. We would be isolated in a fragment of reality. The puzzle falls apart. False vacuum. We are sitting on a ledge. The unobservable universe might have already fallen. The bubble of death is expanding. We are enjoying the view from the cliff, unaware that the avalanche has started behind us. The silence is just the sound of the shockwave traveling. Dark matter halos. Galaxies live in them. They are huge. The unobservable universe is a web of these halos. We see the lights, stars, but the mass is in the dark. We are like fireflies in a dark forest, thinking the light is the only thing that matters. The forest is made of trees we can't see. The trees are heavy. Cosmic variance. We only have one universe to study. Sample size of 1. We can't do statistics properly. The unobservable universe contains the other samples. We are doing science with n equals 1. It is bad science, but it's all we have. We are guessing the shape of the dice from one roll. Timeline of the far future. 10 to the power of 14 years, stars die. 10 to the power of 40 years, protons decay. 10 to the power of 100 years, black holes evaporate. The unobservable future is long, unimaginably long. We are living in the first instant. The flash of the camera. The rest of the movie is darkness. We are the opening credits. Iron stars. If protons don't decay, matter fuses to iron. Cold iron spheres. The unobservable universe becomes a junkyard of rusted stars. Silent, cold, heavy. The ultimate monument to entropy. An eternity of rust. Dyson spheres. Blocking the light. If aliens build them, the star disappears. Maybe the unobservable universe is full of stars, but they are all boxed in. Stellar occlusion. We see darkness, but it's actually infrastructure. The universe is fully urbanized, and the lights are all inside the buildings. We are the rural wilderness, still seeing the naked sky. Kugelblitz. Black hole formed from light. If a civilization focuses enough lasers, they can make a black hole. A weapon? An energy source? The unobservable universe might be a war zone of light weapons. We see gamma ray bursts. Are they natural, or are they artillery fire? Zero-energy universe. The positive energy of matter cancels out the negative energy of gravity. Total energy equals 0. The universe is a quantum fluctuation of nothing. The ultimate free lunch. The unobservable universe is just a balanced equation. +1 and -1. It sums to 0. We are a mathematical trick. Recursive universe. Black holes contain universes. We are in one. We have black holes, they contain universes. It's turtles all the way down. The unobservable is the layers above and below us. We are level 42 of an infinite game. Final anthropic principle. Intelligence must exist to observe the end of the universe. If we die, someone else must be there. Or we must evolve to become the universe. The unobservable universe is waiting for us to grow up and take control. Or it is waiting for us to die so the next candidate can try.